small pieces that remain to be discussed as the last part of the discussions that we have today for memory. First of all, I need to kind of discuss about working memory a little bit for you. We discussed about working memory. In terms of working memory is a process that is something like a gateway to the other types of memory. So we need to have things in the memory, the working memory, to have them in other parts of the memory. So we discussed about that before together. There are studies in animal models like macaque monkeys about memory, and as you can see here, this is what we call DLPFC, and this is what we call ventrolateral prefrontal cortex, or what we call IFG, inferior frontal gyrus. And it seems that we have a structure really close to DLPFC in macaque monkey, in the same way that we have in human. And the interesting part is that when we give those kind of macaque monkeys a stimuli, and they are supposed to wait for a few seconds, let's say 10 seconds, 20 seconds, and then they will have another stimuli, and they need to find the part that has the same color. So they have been exposed to blue, and they are supposed to find blue again in the next pattern. So they need to keep this information in their mind for a few seconds. These are neurons in DLPFC. There are neurons in DLPFC that during this delay period, they remain highly activated. So it seems that in DLPFC we have two types of neurons. One type of those neurons are going to remain highly activated to keep that memory in the brain. And they have been called as something like working memory neurons. So it seems that DLPFC is important in terms of keeping that information in your brain for a while, to be able to find the right answer after something like a few seconds. And they are being rewarded after kind of finding the right answer. So they can learn this task in terms of maintaining the information for a few seconds to get sure that the information would be used in the next step. And this is exactly when the brain is, or those neurons are being recorded. You can see those neurons have a kind of a baseline activity when we expose them to the cue, and then in the delay period, we have a higher activation in the delay period, and then they respond, use the information, and then the activation would be gone. So these neurons are active up to the time that they use the information, and as soon as they use the information would be gone. So these are the neurons that are playing a role in what we call working memory in DLPFC. And it seems that in human subjects, we almost have the same type of response. Here we cannot do the neuron recording. We just have fMRI, and we discussed about this signal before. This is the percent of signal change in bold. So we discussed about blood oxygen level dependence. So it's about oxygen, changes in the level of oxygen signal that we have here. As you can see here, this is the kind of the delay that they are supposed to keep the information in their brain. As you can see here, the response is going to be starting few seconds after the initial kind of delay period, because we know that bold is lagging behind for a few seconds to get started. And then as soon as they use the information here, I mean, there is another lag here, the activation would be down. So they use these parts of the brain to keep the information for a while, and this is what we call working memory. Okay, that was kind of a really rapid overview about working memory. It might be interesting that there are some other ideas that it seems that working memory, it is not just about DLPFC, and it seems that there are people who say that DLPFC is just the center that is responsible to execute the process, not to keep the information. So the information is not actually being stored in DLPFC. The information is being stored in other parts, in down part of the cortical areas. But the DLPFC is responsible for executing this kind of information manipulation or keeping the information alive for a few seconds to be used in the next phase. So this is what we call kind of working memory, but it is going to be critically important to understand the working memory, because it seems that working memory is going to be important for making new memories. But then the question would be, okay, if I disrupt the function of DLPFC, could I just disrupt the process of memory encoding? Because we have discussed that when we have a specific part of information, the information should go into the working memory first, and from working memory to memory. If I disrupt working memory, then the memory would be gone. But in reality, people realize that, different parts of the prefrontal cortex would have different types of working memory involvement. So there are pieces that are involved in working memory related to one piece of your visual spatial field. There are neurons that are related to other spatial fields. So they are pretty much specific to different pieces of working memory. And most of the time, you cannot disrupt all the network. So you just disrupt one part of the network, not the other parts. And then there are people who are really bad in, let's say, the verbal rehearsal, so they cannot use their verbal rehearsal for encoding memory. But they are really good in visual spatial sketchpad, so they can use the visual part of their working memory to be able to encode information in their memory. So people have different, let's say, working memory capacities to be able to make memory. Sometimes there are people who are not really good in the verbal part, but they are good in the visual part. And vice versa. There are people who are not really good in the visual part, but they are really good on the verbal part. So they can use different pathways of memory to be able to encode memory at the end of the day. So, that is another aspect that is going to be important. Okay. And now the last pieces of what we have been discussing about today, and discussing about how these things are being processed in the brain. Just a really short part about what we call amnesia or impaired memory. Various different types of amnesia. We have retrograde amnesia. We have anterograde. So it means that we have an impairment in retrieving the previous information, or we have problems in making new memories. In both sides, we can have kind of amnesia involved. We know that in both retrieving information and recording new information, hippocampus play a significant role. So without hippocampus, we are not able to do any of these two jobs. But if we have a memory that is well consolidated in cortex, it can be retrieved without hippocampus. So those who have injuries in hippocampus, they can still retrieve very well consolidated information in their cortex, but they cannot basically make new memories. Because even if you want to make new facts in your cortex, you need to have the inputs from hippocampus, because hippocampus is the main player to make those highly consolidated memories in the cortex. Without the initial role of hippocampus, you cannot make those maps. But without its role, those maps, some of those maps could still be activated because they are there right now. So they are not going to be affected. There are some specific cases that are related to kind of hippocampal injuries. Just two cases I will kind of tell you in just a few seconds, a few minutes. One famous case is Clive and Deborah. Clive and Deborah Waring, and that this specific case, this gentleman Clive and Deborah, his wife. Clive had a virus infection in the hippocampal area, and he basically lost his hippocampus entirely. And because of that, he had just something like 30 seconds of working memory without any long-term memory. So that is the kind of the book that his wife wrote about their experience, that's called Forever Today. So he was not able to kind of record any information, but he was still able to bring in kind of memories that are related to past experiences before. All those things that are really relative, kind of really factual or highly encoded in cortex. But anything that is going to be formed today, or anything that is related to his own autobiography, was gone. So he didn't have any of those memories. So his wife, because of that kind of really well encoded memory in the cortex, but he was not able to bring any specific memory, any specific episodic recent memory related to last few years before the actual injury. And there are specific, let's say, pieces of that kind of memoir that are kind of striking me when I kind of see those pieces. For example, just after being out of status, Clive was there. So he had a long-term coma because of that herpes infection in his brain. Whenever he came out of that comatose state, he just picked up the phone. He called his wife, making something like a phone call, kind of recording something, then that's answering machine. Okay, it is 5 minutes past 4. I'm just back. It's the first time I have not spoken with anybody else. And then another phone call, another message on the kind of voice recording message on the phone. It's 4:15. I'm awake. I want to see you. It seems that nothing. It seemed that he didn't have any memory about what was happening before. And then another time, something like 18 minutes past 4. So you can see that he was just repeating that specific behavior without having any memory that he called his wife before. So that is another kind of really striking evidence how our memory is playing a significant role in terms of having a sort of a sense of continuity. Sometimes it's illusional. We are not exactly the same person every single day, but we still have a sense of continuity that we are the same person. As you can imagine, without that memory, that specific sense would be gone. And it seems that he has a sort of repeated experiences or repeated behavior without having any flexibility. And there are ideas that he might also be experiencing some sort of DLPFC injuries as well, because we are not controlling the virus, so the virus is making lots of injuries in other parts of the brain as well. So it was not really just limited to hippocampus. But there is another case that he was well known as HM case before his death when he was 82 years old. So that HM case, now we know his name because now he's dead, and so they decided to just kind of open up his confidentiality in terms of his name. But what has happened to this specific case, they removed his MTL totally because he was experiencing seizures that was originating from MTL, and his neurosurgeon decided to remove these impaired part of the brain, while the neurosurgeon was not well informed that, okay, if I remove these pieces, then this gentleman would not have any ability to be able to make any new memories, and even being able to retrieve any memory from past. So that is a really sad story, but this case was really helpful to understand what we know about memory. And we definitely kind of should acknowledge, this specific case, besides the really sad story about him. And the neurosurgeon and his team afterwards, they tried really hard to understand things about memory, and they tried to kind of compensate what they have done. I mean, obviously it was not compensable, but at the end of the day, they tried to see how they might be able to kind of understand things about memory based on the kind of really bad error that they have done in terms of removing those pieces from the brain. The understanding that we have about memory is really related to those cases. Okay, so I think that is kind of enough in terms of the kind of the amnesia and the kind of disorders of memory. There are definitely lots of other details in terms of the problem with memory. So I'm going to stop here for the memory and just go to the last part of the session that we have today.